All right, y'all. So, today I want to go over some of that, sweet SOH CAH TOA stuff we've been going over, but specifically understanding and building up on how we solve this kind of thing when we are finding a missing side, right? And so the majority of this time when we're working with these kinds of problems, it's normally applying to right triangles. It's a little funny looking. And so an example of this would be just being given a right triangle like so, and being given information. So we may be given that the angle right here is 32 degrees. We may also be given that this leg over here, it's an unknown, but it is labeled with a variable. And then our other leg maybe has a measurement of 5. No units on there, just call it 5 units. And so when we look at this kind of problem, you're first thinking, okay, that's a right triangle. I know where my right angle is. I am given a degree measurement. I'm given an angle. I'm also given some information about this leg right here. It's variable x, and this leg has a value of 5. Notice you don't have a value in this area here for the hypotenuse, and we'll get to that. But the very first thing you always want to do is label your sides based off your right angle and based off the other given angle in this right triangle. And so first thing I like to do, you can do it in whatever order you'd like, is I pay attention to my right angle. And I need to remind myself that across from my right angle is always my hypotenuse. I'm going to label that as h. I'm also now going to focus on my given angle and remembering to look across or opposite of that, meaning that across from my 32 degrees, this entire leg, aka variable x, is going to be the opposite, and I'll use the letter O for that. And so what remains, right, we have our degree measurement right here. If we look next to, is going to be your adjacent. I can label that A. But like I said, most of the time what I like to do is label the hypotenuse first, label your opposite, and by process of elimination, you know that your other remaining side is going to be the adjacent. You can do that in a different order, but that way it leaves less room for error on how you label. Next thing you want to ask yourself, right, whether it's provided or not, is reminding yourself of SOH CAH TOA. And so a lot of the time, it's nice to write yourself the SOH CAH TOA just like this. And then based off how you've labeled, right, I said we do have some info on the opposite. It looks like we have information about our adjacent. We labeled this as the hypotenuse, but because I have no information, right, no units of measurement, I don't have a label there, then that means I don't really need to consider this when I'm choosing which trig function I'm going to be using. And so based off this, it looks like we do have the O and we have the A. And so I'm going to look over here and I'm going to decide, okay, which of these trig functions involves the opposite and the adjacent? And then you'll see that this one does not, but the TOA does. And we need to remind ourselves that TOA is going to refer to our tan or tangent trig function. And I'll just leave it as tan. And from here, we need to set up our algebraic equation. And so TOA is written like that for a good reason. We need to focus on this fraction right here, this ratio, the ratio being opposite over the adjacent. And so we go back to our right triangle. And we're like, okay, it's going to be opposite over the adjacent, not adjacent over the opposite. Make sure you rewrite it in the same way, meaning that our O is going to have a value of, let me do this in a different color below, O over A, aka x over 5. And it's really important. Set that up correctly. And you're going to set that equal to your trig function that you chose, which, as we remembered, was TOA, aka tan. So I'm going to rewrite that as tan. And when you type that into your calculator, which I'll show you in a bit, it'll come up in the same way. You would just hit tan or the tangent button. It'll give you a parentheses. And you need to remember that what goes inside that parentheses is actually the degree measurement you are given. Do not be entering this right angle right here. Enter the degree measurement. So that would be 32. Close that up. Fractions can always be written as over 1. From here, we don't have to put in anything to our calculator yet. What's important is that you have this set up based off all the information from earlier. And so what would follow next is you can cross multiply. So I'm going to take x times 1. I will write that down here. That is still just x. Don't forget to bring down your equal sign. And then I will cross multiply tangent 32 with 5. And that's not something you do in your head, but I'm just rewriting what we are doing. So I said tangent 32 will cross multiply with 5. So reminding yourself, what are you looking for? You're looking for a missing side. That's that x value right here. And what goes into your calculator would be this information right here. You can write that in a different order if you want. You may also write, 5 times tangent 32 and then hit enter. This is just the way that I ended up with it. And so I can show you on a different screen. Oh, let me back that out a bit. This is a TI-84. We use the TI-30XS normally, and I can have that set up as well. And so let me move that ad. What I can do is first make sure I'm in degrees, which I'm not. That's always very important to check with your calculators. Notice what's blinking is now in degrees, and I hit enter to make sure. Clear out your calculator, and we said that we're going to take 5 times, actually let's do it in the order I wrote it. Tangent, I already forgot now. Oh, that was tangent 32 times 5. Let me clear that one more time. Tangent 32, close that parentheses, times 5. Hit enter on there, and you're going to be given this long decimal. So it looks like 3.124. If you're in my class, I've asked you to round that to either the 10th place or give me the 3 first decimal spots and then round that up. So why don't we go ahead and write 3.124. So I'll take you back here. X is 3.124. And you may leave that as your answer. And reminding yourself again, we just found a missing side. We'll do one more example of this, and I'll do it off of the classwork. So I'm going to go ahead and jump over there. What's nice about these problems, this is page 10, by the way, on our classwork, is that we are given the nice setup of the SOH CAH TOA. But if you're ever in a situation where it's not given to you, remember to rewrite this for yourself on the side. It just makes that process a whole lot easier. So I'll just pick any one of these. Maybe let's go with number 4. Okay. So number 4 here, we have a right triangle. Remember, first step, label. So easiest thing to label is identify your right angle, look across. That's your hypotenuse. I'm going to label that with an H. The next thing is what is the given angle. Look across. That is your opposite. Want to label that with an O. And then that leaves, the adjacent as the other side. Next thing is, am I given information for the hypotenuse? Yes, I am. Am I given information for the opposite? Yes, I am. What about the adjacent? Nope, sorry. So all I really need to pay attention to is H and the O, and I'm now looking over here. Which one of these 3 trigonometry functions involves the opposite and the hypotenuse? In this case, that is going to be SOH, or the same thing as our sine or sin trig function. I like to X these out just to not get them confused. And now we can set up our equation. So opposite over hypotenuse, based off this info right here. My opposite on my right triangle is 12. My hypotenuse is now x. And you might be thinking, wow, this equation looks kind of different because why is the x on the denominator spot? And we'll show how that works. But remember, equal sign, use your trig function. That is going to be sine. What goes inside that parentheses? The angle, that is 29. Fractions can always be written over 1. Same process of cross multiplying. So let's go ahead and take these two together. You can't really do that in your head. Remember, we're solving for x. So the way I'm going to write it is, let's do x times sine 29. Bring down that equal sign. 12 times 1 is 12. And you should remember from just solving for a variable in an equation, you want to isolate this x. Multiplying is going on. So then we must divide both sides by what I want to get rid of, which is sine 29. And I'll do that in a different color. Dividing by sine 29 on both sides. Whoops, sine 29. This cancels out very nice. Isolated my x, running out of some space. And now instead of writing some multiplication on our calculator, it looks like we have something different to type in. It looks like 12 over sine 29 or 12 divided by sine 29. And so make sure that when you're setting up this part, all things are in order, because if not, there's cases where this might get flipped. And if those are flipped, you're getting a different answer and not the correct answer, not the correct missing side that you're looking for. And so 12 divided by sine 29, I'm going to jump to my calculator. 12 divided by sine 29. I'm going to close that parentheses. I just like to do that and make sure. Hitting enter. And so I have 24.7519848. I like to keep up to 3 decimal spots after. So 24.751, but we have that 9 on the right is going to round it up to a 2. So I'm going to write my final answer as 24.752. Wow, what'd I do? 24.752, and that would be your final answer there. And so those are the 2 variations that you'll see the problems in. So we looked at one earlier where this equation here, we had our variable on top, and it was much easier to just cross multiply these and notice that these are what goes into our calculator. And then we have a different situation, right, in the classwork, where when we did set up our ratio in the sine trig, or the trig function of sine, we end up with a different equation, and we had to do a couple extra steps, which were to divide. But regardless, always make sure you are labeling first. That is going to save you in choosing the correct function. The hard part might be actually setting up the equation. Once this thing is where you want it to be, then you should have no issues getting to a correct answer.